Welcome to Chapter 6, where we'll discuss queues and decks. The objectives of this chapter are first, learn how to represent a waiting line and how to use the functions in the queue ADT for insertion, removal, and for accessing the element at the front. Second is to understand how to implement the queue ADT using a single linked list, a circular array, and a double linked list. And third, to understand how to simulate the operation of a physical system that has one or more waiting lines using queues and random number generators. Fourth, to introduce the standard library deck class. Queues, like stacks, are a widely used data structure, and the queue differs from the stack in one important way. Recall that the stack is a LIFO list, meaning last in, first out. So the queue is a FIFO list, first in, first out. The queue abstract data type. Now, a queue can be visualized as a line of customers waiting for service, and the next person to be served is the one who's waited the longest, and new elements are placed at the end of the line. Now, to the left is a queue of 3 customers waiting to buy concert tickets. Tomei has been waiting the longest, and Jones is the most recent arrival. Now, Tomei will be the first customer removed from the queue to buy a ticket when the agent becomes available, and Abreu will then become the first one in the queue. Any new customers will be inserted in the queue after Jones. Operating systems use queues to keep track of tasks that are waiting for a scarce resource and to ensure that tasks are carried out in the order they were generated. So a print queue is typically much slower than the process of selecting pages to print, so a queue is used. We would not want our printer to support a print stack, because stacks are last in, first out, so the most recently selected document would be the next to print. So unless the print stack is empty, your print job might never be executed if the printer is connected to a computer network and others are issuing print jobs continuously, and so your job could be left off indefinitely. Here's the specification for a queue interface. Here are the functions and their behavior. We have a Boolean empty function. We can get the front element of the queue without removing it. We can pop to remove the front of the queue, similar to popping a stack, and we can push an item onto the rear of the queue. And we can get the size of the queue. Now, because only the front element's visible, the operation is performed by a queue or few, and we need to be able to retrieve the front element, remove it, push a new element onto the queue, and test for an empty queue. And these functions are all defined in the header file for the standard template libraries container called queue. Here is the queue header file. We include a list because the private data field in this implementation is going to be a container that's a list type. And it's a template class, so will contain the member functions in the header file just after the class definition, but before the end of the namespace. Now, for the queue names in A, the value names.empty is false, and the statement first equals names front, it'll store Jonathan in first without changing the names. If we pop the queue, Jonathan is removed and we'll be left with these 4 names. And if we push Ileana onto the queue, Ileana is added to the end of the queue, and we now have 5 elements. And that's the end of this slidecast.